Hi, welcome back to LeetCode. So in this one discuss the second problem from today's bi-weekly contest. The problem name is minimum removals to balance array. So you are given an integer array nums and integer key. Okay, an array is considered balanced if the value of its maximum element is at most k times of the minimum element. You may remove any number of elements from nums without making it empty. So return the minimum number of elements to remove so that the remaining array is balanced. So that means I actually have some input array and we have actually have k. Now what I have to do, I have to return the minimum number of operation we need, means we have the minimum number of elements I have to remove from the input array such that the array should be balanced. So what is balanced? So that means whatever array I will have, resultant array you can say. So in the resultant array, what is the minimum element? Suppose minimum value is x and the maximum value is y. So that means x into k, that should be greater than equals to y. That means the maximum element value should be at most k times of the smallest value. Got it? So in the resultant array, I will actually have some minimum value and the maximum value. So if I actually multiply the k with the minimum value, so it should be greater than equals to y. Then I can actually say that this will be actually balanced. Clear? So I actually have to check that to make an array balanced. So how many actually minimum number actually we can actually minimum operation means minimum number of elements I have to remove from the array. So how many actually minimum number of elements I have to remove to make the resultant array as a balanced. Got it? So for this, suppose this is our example 1. This is your input array 2, 1, 5 and k is equal to 2. So suppose I am assuming this is the minimum element 2. So what is the maximum number it's allowed? K into the minimum value. The rule is k into minimum. So maximum value will be that, because maximum value is allowed actually x into k. So here is 2 into 2. That means 4. So what will be the resultant array? If actually make this the array, discard all the elements that actually smaller than 2 and discard all the elements that actually greater than 4. That means greater than max value. So after that many numbers I have to do to make this array actually this range, that minimum value should be 2 and the maximum value is 4. So what is the resultant array? It should be like 2. 2 will be present, 1 will be present. No, this is actually smaller than the minimum value, so it will not be present. 5, yes, this is greater than the max value, so it will not be present. So our array will be 2 only. So how many operation I have to do? 2, because I have to remove 1 and 5. Clear? Similarly, next assume that this 1 is our minimum element. Got it? So what is the maximum number it's allowed? 1 into 2, so this will be 2. So what is the resultant array? If you actually make the range, that is the smallest number, it actually range will be 1 between 1 and 2. So 2 will be present, yes. 1 will be present, yes. 5 will be present, no. So our resultant array will look like 2 and 1. So how many operation I have to do? 1 to make this balanced. This now you can just see this array is balanced because I have already bounded the range. The minimum value I am assuming this 1. So maximum value it's allowed is equal to 1 into 2. Next time assuming this 5 is our minimum element. So what is the maximum number it's allowed? 5 into 2, 10. So what is the resultant array? So 2 will be present? No, because 2 is smaller than the minimum value 5. So 1 can be present in the resultant array? No. So 5 can be present? Yes. So resultant array is contain only 5. So how many operation I have to do? 2. So out of all these operation to make this balanced, so how many minimum number of operation I have to do? 1. So this will be our answer. Clear? Let's see another example. Example 2. So for this example, the input array is 1629, k is equal to 3. So what is the minimum number? What is the maximum number it can be have? And the array after this applying this range, minimum value and maximum value, what will the array look like and the number of operation I have to do. Clear? Suppose minimum value I assume first element y 1. So maximum value it will be 1 into 3. So 3. So what will the resultant array look like? 1 can you present, 6 not present because the maximum value is allowed 3. So this crosses the maximum value, so it will not be present. 2, yes, within this range between 1 and 3. 9 can you present? No, because this actually cross the max value max value 3, so it will not be present. So resultant array will contain only 1 and 2. So how many operations I have to do? Total I actually have 4 elements. So 4 minus 2 I have to do 2 operations. Two operation means two elements I have to remove from the array. Clear? That actually 6 and 9. Next, I am assuming that 6 is actually our minimum element. So what is the maximum number actually I have to allow? 6 into 3, 18. So what is the resultant array after applying this range? So that will be 1 can you present? No, because this is smaller than the minimum value it is allowed. 6 can you present? 2? No, it is smaller than 6. 9 can you present? Yes, within this range. So it will contain only 6 and 9. So how many operations I have to do? 4 minus 2 again 4. 4 is the total input size, and in the resultant array actually I have 2 elements. So that's why how many elements I have to remove? 4 minus 2. Similarly, assuming the minimum element is actually is 2. So what is the maximum number it's allowed? 2 into 3, that is 6. 1 can you present? No, because the minimum number actually I have allowed 2. 1 is smaller than minimum element, so it not will present. 6, yes, 6 can you present because the maximum value I have allowed 6, so it can you present. 2, yes, this is the minimum element, it can you present. 9 can you present? No. So see here also I have to do 2 operations. 4 minus 2, 2 operations. Clear? Next I am assuming 9 is our minimum element. So what is the maximum number actually I have to allow? That will be 9 into 3, 27. 1 can you present? No. 6 can you present within this range? 9 and between 27? No. So it will not be present. 2? No. So 9 can only present in the resultant array. So how many operations I have to do? 4 minus 1, 3. So what is the minimum number of operations I have to do? 2. To make the resultant array balanced. So you can just see for this example 1629 input array and the k is 3, the output is 2. 2 number I have to remove. 2 elements. Clear? And for the example 1, you just see that I got minimum answer actually I got 1. Here also the output is 1. Clear? Now, so this is actually the brute force approach. How? I am actually for each I am assuming this is actually the minimum element. Then again I actually iterate the whole array to check that which number can you present, which number I have to remove, to count that. Count how many numbers present within this range. Because for this I, nums of I actually assume this is a minimum element. So I can easily find out what is the maximum element I can actually allow with this minimum. That will be k into minimum. Got it? Now I know the range. What is the minimum number actually I can actually allow, and what is the maximum number. Now again I have to iterate the input array with this corresponding with using this current range, mean and max. So this will take big of n if the input array is length n. So because I have to iterate each element that it can be present in the resultant array or not. So it will take actually big of n square. Clear? Actually n square. First this for I, this will take big of n because I have to check each individual, assuming that each number is a minimum element. So that will take big of n, and for each minimum I have to check that which number can be present within this range or not. Got it? So this will again take big of n. So this is a nested condition, so that's why it will take n square. So it will actually obviously give us the TLE, because here you can see that n value, the length of the input array is 10 to the 5. So it will actually take 10 to the power 10. So it will be greater than 10 to the power 8. So it will actually give us TLE. Clear? Now how will I optimize this? So if I actually sort the array, now it will be easy to understand. How? So suppose for this example 1629. So if I sort this array, so the array will 161269. Clear? After sorting the array, input array. So what actually I have in the brute force approach, what actually I am trying to do? Why actually I am to iterate the each element? Why? Because this is unsorted array, so input array is not sorted, so it can be present anywhere that each number can be, any number can be present in within this range, right? So that's why I have to iterate each element. But if I sort the input array, now actually I have to sorted array. Now if I assume that this is actually the minimum element, now I can actually know what is the maximum rightmost actually I can go. Got it? Because I can suppose this is actually our minimum L actually I actually have. Now I know that maximum I can go up to 1 into 2. So I actually know the R can go up to 2. So 100 R go to actually 6. So I have to stop there. I know this is crossing the range. So that's why if I sort the array, then actually I have fixed the ordering. That means I know that whatever the number actually, suppose 1, 2, 6, 9. Suppose this is actually our 6. Okay. Suppose I am assuming this is a max element. Okay, the rightmost element of the balanced array. So what is the leftmost actually index actually I can actually have? That will be 6 should be less than equal to the k into nums of L. So if the condition is true, then L is the leftmost actually the index. Got it? So what actually I have to do? This is clear. That means try to maximize the length of the balanced array. So how can I maximize the length of the balanced array? Because ultimately what I am trying to do, n minus total input length minus the resultant array. Right, resultant array. So that's why if I actually increase the resultant array, length of the resultant array, so it will actually ultimately decrease the length of the input our answer. Got it? That is we are trying to evaluate that value. Got it? So our target should be increase the length of the resultant array or the length of the balanced array. So how can I actually increase that? So I will assume that I know this is actually the minimum. So this is actually the minimum element. I'm assuming, but I have already sorted the array. So I'll check that how much actually rightmost position actually I can go. How can I check that? So I have to check that this current with this current L, that means R nums of R is less than equal to nums of L into K. I can actually go to R plus plus. This is clear. This is clear. How can I maximize the length of the balanced array? So just fix the minimum element and go to the right and shift the right pointer. Right pointer is pointing the rightmost or the maximum element actually I can actually have. So I know, suppose 1, 2, 6, 9. So this is actually our left pointer. So this is the and right, both are actually pointing to the same. So this is actually okay. One element is always our best, always an answer, valid answer. So now I try to take this 2 is possible as our right with this current minimum. Yes, how to validate that? So that's why I will check that in this way, that whatever the value actually nums are actually pointing, that should be less than equal to k into nums of L. Got it? So 1, 2, 6, 9. So left is pointing here, first over right is pointing here. Okay, this is valid. So our answer will be R minus L plus 1. So that will be 0 minus 0 plus 1. So length is 1. Okay. Next, shift the right pointer here. 1 and 2. Just see the image. So right is pointing here and L is pointing here. Yes, this is still true. So length will be R minus L plus 1. That will be 1 minus 0 plus 1. The length is 2. So our answer will be now 2. Clear? Now next, shift the right pointer here. Now with this, like I have to balance the array. So 1, 2, 6, 9. Sorry. 1, 2, 6. This is now our left and this is our right. So is this balanced? No. Why? Because with this minimum, I can go up to maximum 2. So I have to shift the left pointer. Till how much I have to shift the left pointer? Till actually this is not a balanced array. So that means I have to shift till our actually nums of R is greater than K into nums of L. So till that time I have to shift the left pointer to the right side, because I know if I actually shift the left pointer to the right side, so it may actually increase the value of the minimum element. So that time it may possible that this R will come into the within the range. Got it? So that's why now left shift to this side. Is it now valid? 2 and 6. K here actually it is 3. So yes, now it is valid. So this is actually one valid answer. So what is the length? R minus L plus 1. Length will be, this is 0, 1, 2. That means 2 minus 1 plus 1, it actually 2. Length is 2. Our answer already best answer is 2. So this will not be modified. This will not be modify the answer. Got it? Next, 9. So right pointer shift here. So is it possible with 2, 6, 9 as a balanced array? Left here is still 2 and right is pointing now 9. So is it a valid balanced array? No. So I have to first shift the left pointer here. Okay. So now it is valid balanced array. Yes, because 6 into 3 is less than is greater than equals to 9. 18 is greater than equals to 9. So this is a balanced array. I have already, how much validated this is a balanced array? Because I have already sorted the array. So I know that whatever the number is present within this range, in between L and R, all actually within this range. Got it? So this will all actually valid array. So that's why first we need to sort the array. That's why we don't need to check all the elements big of n. If actually validate the left pointer and the right pointer, means the minimum value and the maximum element, then actually I know that whatever the number is present within this range, all are actually valid. That are actually within this range. Got it? So that will be, what is the index now? 0, 1, 2, 3. So the length will be 3 minus 2 plus 1. That is actually 2 again. So this is already best answer. So our answer will be ultimately 2. Clear? So that's why just go to actually code. So first of all, I have to maximum length. I have to have to know the maximize the length of the resultant array, resultant of the balanced array. So our target is to maximize that. So that's why it is start from 0, and left pointer is pointing at index 0 and right pointer also pointing at 0. And I have to know how much number is present in the input array. So this will in. Now first of all, sort the input array. Actually I'm sorting this array because usually if I know the two pointer minimum, the left pointer and the right pointer within any array, I know that whatever number is present within this, in between of this index, that actually all actually within this range. Got it? So that's the first sort the array. Now run this while loop till actually we have some element in the input array. So I have to check what, first make the array is a balanced. So how actually make this balanced array? So if I see that what the minimum number is present, so now minimum number is present at the index L, nums of L. So I multiply with k and check that for the right pointer is pointing, is this greater than that k times of the left pointer. So that time I have to shift the left pointer, left plus plus L plus plus. Got it? So it will run till actually left pointer, the minimum element is maximum number is less than equal to k into minimum element. So this while will run that time till that point of time. Now after that actually I have the length of the I actually have the two valid pointer. One is the minimum element, one is the right pointer is pointing at the maximum element of the balanced array. So I can easily find out what is the length of the sub array of the array of the resultant array, balanced array. So that will be r minus L plus 1. So I have to maximize that, our target is to maximize that. So take the maximum of value and store this again maximum length and the shift the right pointer plus plus, because next take the next number, nums of r. So that's why go to the next number. Ultimately after this while loop, in the max length value variable, actually I have the maximum length of the balanced array I can actually generate. So if I know what is the maximum length actually I can generate of the balanced array, so I will subtract total input length array n minus the maximum balanced array. If I subtract that, that will be the minimum number of operation I have to do, minimum number of elements I have to remove. Got it? Clear? This is clear that why I have to sort to optimize the search, because after sorting I know that whatever the range actually I have between index 0 to suppose 2, that number actually within this range, mean and max. Clear? So that's why we need to sort, and then we can easily shift the right pointer till actually our left pointer is within this range. Within this range means the maximum number is less than equal to k into the minimum element. Got it? And if it is actually violate the condition, then actually you have to shift the left pointer only, because I have already explored. Suppose I have already explored, why actually shift the left pointer? Suppose I have already explored with this L and R, right? Now if I actually shift the right pointer, is it possible to get the better result? No, because I have already explored this area. Now if I explore this, if I shift the left pointer right side, then actually it may possible that I can actually add some element into the array, in the balanced array. But if I shift the right pointer here, I have already explored this area, right? Because I have explored the right pointer plus plus r plus plus. So I have already explored this range 0 to 2, and now actually I mean suppose in index 3. So if I see the right pointer to the left side, so it will actually already it will not give us the best answer because I have to explore this range. So that's why I have to explore the shift the left pointer to the right side. Clear? Then it should be possible the best answer. Clear? I hope this is clear. And if you have any doubt, any suggestion, you comment on that. And if you're not yet subscribed, please subscribe channel. Thank you. Bye.